Hello. Daniel, you definitely justify your presence of being here, so thank you for letting us. And it's nice to be here in Berlin, actually. We're from Sweden. My name is Erik Eklund, and I work as a BI analyst and also with the data science environment at SvenskaSpel. I work very closely with the business side of things, especially with business controllers, developing dashboards and analytical applications. It's a long time ago, but at the age of 4, me and my family moved to the United States. So if you could detect the American accent, it's because I lived there as a child, but I'm all Swedish, but I speak a little bit American English. So that's me, Sami.
Yeah, hi, my name is Sami Landström. I work as a consultant at SvenskaSpel from Sparks, and I've been there for 1.5 years almost, and worked with the Exasol implementation, and now I'm doing a lot of work with GDPR, which is important for us. So the agenda for today that we're going to look at is sort of how we ended up with Exasol and the journey to that, and then look into our platform. So where does Exasol fit within that? And then we're going to show 2 demos on how where Exasol helped us out a lot, and then summarize with some learnings and conclusions about Exasol. So how did we end up with Exasol? We started out with the ordinary BI solution, and just as we've heard a lot about this morning, we tried out Hadoop a couple of years ago. And it ended up looking a little bit like that. So we started out with Oracle Exadata and Cognos. And then 4 years ago, we started to look into Hadoop and migrating to there. And at the same time, we also started a project with new slot machines within all the restaurants in Sweden, and that started to generate a whole lot of data that Exadata couldn't really handle. So those 2 projects went hand in hand to drive Hadoop. At the same time, we also wanted to drive data analytics, self-service, and especially data exploration more, so we started a project with Tableau as well. So everything up in there at the same time. But that more or less ended looking something like this. So we had a lot of users that were accustomed to standard BI systems. I mean, Cognos was working great for them. And also new Tableau developers that saw a lot of these waiting cycles. And why was that? We had Hadoop, we had Tableau. That should be like great. But we sort of did the same mistake that a lot of people do that go into Hadoop. We picked a tool and probably used that for the wrong reasons. So we, first of all, used Hive and thought that we could just connect Tableau to that. And then first of all, you can't do, it's not a responsive tool. It's made to sort of shift data around, not being a back-end responsive engine. And also for Tableau developers, it became a lot of a hassle to just connect to the data to get their queries up and running. They ended up in Hive queues, etc. So it was all a hassle. And the data we actually managed to get out didn't really fit into Tableau extracts either. So we, at that time, we had around 2.4 billion rows in our fact tables, and we had a couple of them. And our largest dimensions were like 18 million, around that, and also very wide. So if you can probably fit the number of rows into Tableau extracts, but if you also combine that with having 40, 50 properties on those rows, it becomes, you can't do it. We managed to get around 5 months into those extracts in a workable manner. Yeah, and then sort of as a history with our BI department, we also had a history of working with a lot of aggregate tables, so having different levels of aggregates like month and then week and day, etc. And they wanted to get rid of that and only work against transactional systems. And we also had issues with our KPIs.
Yes, because SvenskaSpel is a very customer-centric organization, which is reflected in our KPIs. Measures such as number of customers, number of gaming days, reoccurring customers, revenue, churning customers are intensely discussed through all levels of the organization. How many customers did we have last week online? How many customers visited our retailers the last month? How much revenue did the product Lotto provide us with over the last rolling 12-month period? These are just some questions that the business users asked and wanted to get answers to. So at SvenskaSpel, there was a great need to easily be able to consume metrics on all combinations of product, sales channel, and elements of time. And this actually presents a challenge, because as many of these metrics require account distinct across several levels of the hierarchy for several dimensions. And that is very computational intensive, as probably all of you know in here. And how we approach that challenge and how we work to solve it, we'll get back to later when we take a look at the two cases. So yeah, so sorry, next slide. So let's take a closer look at SvenskaSpel. At SvenskaSpel, as Daniel said, we sell gaming products. If you enjoy watching the Bundesliga, since we're here in Germany, you probably enjoy playing the Europa Tips, which I do quite a lot because I have Spanish football as well. I like the La Liga. So it's we have, and if you'd like to play the lottery, we have Eurojackpot where you can win a lot of money. So. We divide these products into product categories, such as sport games, games of chance, and poker. We further divide these products into product groups, such as sport pool gamings, sports betting, number games, and lotteries. These products are sold through our sales channels. We sell our products through online, through retailers, and some of our products we sell through Vegas partners. Online can be further divided into mobile, into tablet, and into desktop, of course. So from a data modeling perspective, these are just two examples of dimensions containing hierarchies with different levels. This is not unique for SvenskaSpel in any way, and it's actually very common. But we'll come back to them later when we take a look at the dashboards.
So we started a hunt for the performance layer, and we set up some goals. So as Eric mentioned, we wanted to solve these complex measures. That was the base case. So have a solution that could cater for these count distincts and make sure that those also worked against sort of all the data that we had. So we had to do that across rolling 12 months, rolling 6 weeks, etc. And that gave that sort of we had to be on the most granular level. So our transactions, all the sort of bet clicks that you did in a restaurant, or a sporting bet that you placed on a website, etc. We also wanted a solution that could be worked out for self-service. I mean, we had Tableau, and we had to cater for that, so that customers or our clients in the organization could easily hook up to our solution and drag and drop, which is the power of Tableau. So more or less get away from the Tableau extracts. We ended up with Exasol, that's why we're here. But along the way, we sort of looked at some different vendors. Some of them had issues at that time being mature. We were in the Hadoop stack, so we really wanted to have something there. But there, some of them couldn't even count, had the bugs within the sum functions. Some only had estimates on count distinct, so they went out the window. And then quite early we saw that even the demo systems we got, like physical installations of, could be beaten by the Exasol virtual machine. So it ended up being quite an easy choice. So next slides we're going to look at sort of where does Exasol fit in our architecture and how do we work with data. So as mentioned, we work with Hadoop. And we, for most everything, or we have an architectural guideline that says that all data management should be done within the Hadoop stack. And for that, we use Hive. And the benefit of that is that, I mean, we came from a BI world, so it was quite easy to, with SQL within Hive, get up and running and be productive fast. If we look at sort of the input data for us, we have around 300 different event streams. An event could be something from these restaurant slot machines where you click. It could be somebody on a website placing a bet, or somebody playing poker. But it can also be like metadata changes, like odds being changed on a football game while players are playing. And if you look at what those 300 events get turned into, it's about 150 different tables that we, in the end, publish to Exasol. How we work with data is we do something that we call model-based development. So all of these events that we take in, we try to document as well as we can and understand them. It's a quite big organization, so developers of other gaming systems, they just push something into our event stream. So we try to document that and understand it, and then we model it using Data Vault. And we do that in a tool called Oracle Data Modeler, which is free. So that's great. And then we use that model to generate all our tables and schemas. And we also use it to generate some of our data transfers. So the easy ones we do model created, and then some of the trickier ones we actually code. It's also been a great benefit to have this model-based development now with GDPR, because it's very easy for us to sort of tag data within that model and make sure that what the data people should access and not access, and what should be removed, etc., from these events coming in. So if we look at our sort of stack a bit zoomed out, we have all of these events coming in to our data lake, and that's just raw data, so we're JSON and semi-structured data. We turn that into Data Vault, so the model we've created, and then at the end we transform that into ordinary dimensional marks, so you have fact tables and dimensions. And that we just copy over to Exasol. So that made our implementation really easy. We were up and running in about 3 months from the starting point of choosing Exasol. And then that is, of course, consumed within Tableau. So the 2 cases we're going to show today is that I'm going to show a demo of how the change was for people. So going from extract to working with Exasol instead. And then Eric is going to show some more how we solve some of these more advanced calculations. So video, please. Paused. Yeah, so as demos always go wrong, we recorded a video instead. So what you see here, or looking at, is on the left-hand side we have Exasol, and on the right-hand side we have extract. And that's of our sort of core gaming table. As you can see, I'm starting with a filter on the Exasol side to be a bit fair in the beginning. So that's filtering a half year. So the same amount of data that we managed to fit into the Tableau extract. And that took like a day or 2 to just load that extract. Yeah, so if you press play, please. Yeah. So what we're going to do here is to take out this measurement, which is customers. And for the one with the sort of looking at details, these are going to differ because we're doing encryption on both sides and differently, so it's scrambled. But it's the same amount of data that we're looking at. Yeah, so starting to just set up Tableau. At the beginning, it goes quite quickly with the extract as well, and they differ, as you can see. But then as we go along and start to pull in the dimensions, so I'm going to start with sales channel. It goes really quickly at first because I managed to drag out something that was cached. But then if I change sales channel to another level, it's going to start to load. And while I'm doing that, I'm doing the same on Exasol side. So it's already gotten a bit of a start. Let's see. And I mean, now we're just looking at one graph. Imagine a dashboard. So I'm going to start to do it a bit more complex, so start to combine it. So I'm going to drag in a level of our product hierarchy. And here I'm just going to select everything and filter away to products. And this was really part of the sort of success story to give users this experience instead of the waiting glass. So as of this, Exasol sort of sold itself. And then as a last thing, I'm going to pull in something called gift certificates. You can sort of play with those. So I'm going to filter that away to just look at real games. And then do the same thing within Exasol. A bit quicker. So then let's try to just remove the date filter and look at all data. So then we're looking at a couple of years of data instead. It's going to take some time, but here we're looking at like 2.5 billion records or more. And we're doing these count distincts, which on transaction levels does a lot more. And we're done.
It's fast.
Yeah. So that was the first case.
Yes, and and the other case where Exasol has provided large amounts of business value at SvenskaSpel is a case we call flexible aggregates for complex queries. And actually, you could replace the word complex with computational intensive, because the solution, which you'll see later, is quite simple, but the processing power required to calculate some of these measures as count distincts over many levels of the hierarchy for several dimensions is very computational intensive. So we had Hadoop and we had Tableau, and now the business users wanted dashboards providing insights and analytical applications. So what were the business requirements? The business requirements were, they wanted fast-performing dashboards containing the following measures and dimensions: gross gaming revenue, net gaming revenue, number of customers, as we discussed, a number of gaming days, churning customers, recurring customers, new customers. They wanted to be able to drill down at all levels within the hierarchy for several dimensions. They wanted to move to how many customers are online, how many are in the app, how many are mobile, how many are desktop. They wanted to move quickly through the hierarchies of the dimensions. They did not want to wait. And Sammy, you showed us 6 months of data, but my users really wanted at least 24 months of data. So, and in the combination of the rolling periods, the rolling 12-month periods, is very calculative intensive to do. It's very expensive calculations performed. So, what could that look like? Before we go ahead and take a look at the dashboard, let's see, what did we have to work with? What were our prerequisites? Well, we had a 13-node Hadoop cluster, and we had Tableau with its data extracts prior to Hyper. We had transactional fact tables with transactional data, and we didn't have any aggregate tables, and we had non-additive KPIs. So what did we do to develop these dashboards for our business users? We started filling our data extracts with hundreds of millions of rows of data, and we built these dashboards, and we put in a number of customers and count distinct number of gaming days, and we built them and we tested them and presented the dashboard with different levels of the product dimension, and the users waited, and they switched down to how many were visited the retailers last month, and they waited. So we quite quickly realized that this wasn't the way to go forward, and we needed to create aggregate tables. And we created these aggregate tables in the beginning in Hive, and it actually worked pretty well. Well, not that well, I shouldn't say pretty, but one month of these 24 months of data took about 30 minutes to process. And if you scale that linearly for 24 months, that would take about 12 hours. So we started running into the ETL processes and realized this was not really a good solution. So to the rescue, as you probably heard here before, and after Sammy's discussion of what performance layer we choose, so after we chose Exasol, just a couple of days afterwards, I could present this. So you could turn on the movie now. And this is scrambled data, so it looks completely crazy. I mean, it's all scrambled, but the underlying data volumes are exactly the same. So it's just, so this is just an example of how the business users can, just one of the dashboards we created, which the business users select its measures and can drill down on different dimensions. So we can have different levels of the product. It's all in Swedish, it's probably hard to understand. We have different levels of the product dimension on the lower level. And we have millions and millions of customers and billions of revenue. So we have quite a lot of data. So could you turn on the movie? So this is just, now I'm selecting antal kunder. Per month. So I think I'm gonna, we have an info window there. This is so the definitions of the metrics. Then I'm choosing number of customers rolling 3 months, number of customers rolling 12 months, revenue for per month, revenue for the rolling 12 months. But that's an additive measure, so that goes faster. But the antal kunder is number of customers. So I mean, that's very intensive computative intensive calculation. And we're filtering to Stryktipset, which I was, Daniel, that was your favorite product, I think, yeah. There we go, Stryktipset, looks like that. And now let's drill down through the dimensions. And this is exactly what the business user envisioned. They wanted to move quickly through the volumes of data. They did not want to wait. I mean, by this dashboard, they're getting exactly what they want right away. But you could actually, I think I delivered the point, so you could pause it and go back to the presentation, please. Oh, perfect, thank you. So how was this possible? And I already told you that we created aggregate tables, but about the second day after implementing Exasol, I wrote this. And I'm not expecting you to be able to really see the code, or maybe you can, because it's good. I'm not expecting you to see it, but it's a Lua script, a very simple Lua script, which dynamically calculates all the measures we saw on the previous dashboards, grouped by different attributes of the dimensions. And as you can see, this is the complete code for the entire dashboard with the users. And we just saw actually one sheet. There's several sheets. And to do one iteration, which is 1 month, if you want a full load for 24 months, the Lua script will loop through 24 months. And one iteration, 1 month of the data we just saw took an average 28 seconds. And that's a quite modest cluster we have. We just had 2 nodes, I think, with 1 spare node. So it's a quite modest cluster, and we did 1 month of this one iteration for 28 seconds, which took Hive for 30 minutes. So I was completely amazed when I wrote this, and it's so easy to do. You combine the Lua programming language with the SQL statements. So it's flexible and it's fast. The SQL statements run on parallel through the entire cluster, which is fantastic. We've gone through from a very code hard to maintain to a Lua script with very compact code and very maintainable code. So if the user wants to add a dimension or add a level to the hierarchy, it's just go into the grouping sets and add your level or do your join. And it's very, very flexible and fast to work with. But it's not any magic. I mean, we're doing this, we're filling aggregate tables. We're doing aggregate tables. But at the speed of which Exasol performs these calculations, it's very, very impressive. And just as a previous speaker, I do not know how they do that, so that's quite amazing. But as a developer, it's a database developer, it's fantastic to work with. So it isn't magic to perform aggregate tables and work against, but the amount of business value that the users have received through these dashboards are just fantastic. So they love the product, or they love the dashboards which work with the Exasol database. And on our roadmap is actually to do these queries live and not to use an aggregate. So that's on our roadmap. So that was my case. Thank you.
Yeah, so what are the conclusions? Well, as we started, that angry guy has turned into this. So we're off the extracts now, and we migrated all of Tableau to do just live queries against Exasol. It was very easy to implement, so maintainable. We just copy the results from our Hadoop implementation to Exasol. And we have solved some stuff through aggregate tables, but we solved the count distinct, so our business users are happy. Yeah, and if we have some takeaways, sort of what we've learned doing this is a lot of it has to do with Tableau. We're actually working with Tableau to Exasol. And it goes into sort of, even though you have a really fast database, you have to look into what Tableau does. So sometimes it doesn't generate the best of queries. So one point is to make the sort of query analyzer within Tableau your best friend. So to really see what, there's a function to look at audits in Tableau, and you can use that to understand the communication between Tableau and Exasol. So for that, we use a lot of custom queries instead in Tableau. So for the main dashboards that doesn't need to be that free or drag and drop, we use custom queries. And they are amazingly fast. Then another point that we learned during the way, and actually at the user group of Tableau, was join culling. So think of that. So a lot of our implementation, we've used views, and especially to filter out data for security and all of that. So then it loses the primary keys and etc. So Tableau doesn't understand when it can skip joins. So there's a function in Tableau to turn on or sort of trust the relationships, and then it will remove those. And another point is also to set the priorities straight in Exasol. So set maybe the dashboards to have highest priority, and make sure that self-service get the lowest one, so that you always deliver the dashboard that counts. Yeah, lastly, we just want to put out a big thanks. Exasol came in and saved the day, and we've had a lot of help during the implementation and fast responses from the support team, so big thanks.
Thank you.
Thank you.
Thank you.